So sorry, I was on mute. So welcome everyone again, and I hope you are more excited and are waiting for this session on the topic of motion, right? So yes, so today we are going to discuss the fourth session on motion, right? Already we have discussed on three topics. Already we discussed on the motion. In the first session we discussed about, yes, anybody can recollect? Yes, in the first session we discussed about basics, right? Introductory part, and in that only we discussed about distance and displacement in much detail, right? So in the second session we represented graphical things, right? Rectilinear motion, what is called as, isn't it? Rectilinear motion we discussed. Basically, rectilinear motion is the motion in one dimension, right? That's what we discussed in the second session. And in the third session, we discussed about graphical representation of velocity time graph, right? Distance time graph, exactly, very good. Then area under VT time graph represents displacement, right? Very good. And area under distance time graph, that we discussed. Slope, calculation of slope also we discussed, right? In the third session, in the last session. Those of you who have missed any of the sessions, please do sign up and subscribe our YouTube channel and search on that motion. So you'll get all my previous sessions and you can go to them, right? For your better understanding, right? Fine. So let us start our today's session on the motion. Okay. So everyone is ready. Let us start now. So just give me a minute. I'll just share the screen. Each one of you. I hope my voice is audible and continuous to everyone, right? Fine. So hope this is visible to you now, right? Yes. Again, those who are new to this session, right? Just a small introduction about Swiflearn. So Swiflearn is the India's most sincere leading destination. Why we call it as most sincere is because these four reasons. The first reason is we are 100% live. Right now, I'm giving you a live session, right? Everyone. So those who are present here, they can get benefited, right? So it is 100% live, interactive class. You can ask any kind of doubts in the chat section, right? Of course, related to this topic only. Any kind of doubt doesn't mean that any here and there, right? So that's the one specialty, first specialty. Second specialty is we have a personalized attention batch with maximum 6 students only, right? Because see, when the number of students is more, then it's very difficult for a teacher to give personal attention to each and every student, isn't it? That's why we have kept the maximum limit of 6 students in one batch, so that a teacher can give a personal attention to each and every student. That's the whole motto, right? Third special thing about us is a dedicated academic mentor team to track and work on progress. Right? Every student wants to know how far I have come and how far I want to go, how much I have done progress and how much I want to do progress. Isn't it? Everyone agrees with this, right? So we give a regular report, progress report, how much you are doing well, how much you need to do well, right? These all reports are being provided to you, right? So that's the third specialty. The fourth specialty is we cover entire syllabus. No matter because of the COVID, whatever the syllabus has been cut down or whatever it is, we complete all the syllabus because see, knowledge never goes in vain, anytime, isn't it? Knowledge never goes in vain, right? So that's why we are more focused on completing the entire syllabus, and at the same time, we have a custom requests. At your request, we can conduct exams, practice exams, some doubt session, whatever, as per your request. So these are the main 4 special reasons why we are India's most sincere online platform teaching. That is a Swiflearn, right? So next few features here I am representing. These are the few more features. First is detailed progress reports, right? As I mentioned, we give progress reports regularly. Second is SATs. SATs is a very, very special of our team. that is Swiflearn Academic Test Series, right? We conduct so that you get more and more practice of the questions, and at the same time, practice makes man perfect. You might be knowing that, right? Practice makes man perfect, right? So we allow you to practice more and more questions, subjective, MCQs, both, right? So that a student is well to do with any kind of question asked in the exam, right? The third is take unlimited practice tests as much as you want. It's up to you, how much you are, right? So that's the thing. And the fourth thing is subjective tests for school exams. We also conduct subjective tests, right? Whatever the exams, in your exams, it is conducted like unit test or midterm test or whatever tests. We also do conduct that, right? So why to wait? Then please book a free trial class on the Swiflearn platform. And before going ahead, please subscribe to our channel and don't forget to press a bell icon so that you don't miss any of our live updated sessions, right? So everyone is ready now? Well to do? All set, right? Right? So let us start our first session, this fourth session, sorry, on the topic of motion. Here we go. Yes. So in this session, we are going to discuss about equations of motion by graphical method. Okay. Already we discussed about graphical methods in the previous session, right? Just give me a minute. I'll come back to you in 1 minute. Yes, here we go. So we have today with us Miss Akshita. So very happy to see you. How are you? Akshita, please reply. I think you attended my previous session as well, right? So I'm very happy and very glad to have you here. Very grateful, right? Yes. So Akshita is also present and few students are also coming up. Fine. So in this session, we are going to discuss about graphical methods. We already discussed about some basics of graphical methods in the previous session, right? So x-axis, y-axis, coordinate axis, and so on and so forth. Introduction it was. And we also discussed how to calculate slope of the graph, right? Area under the graph, right? Not all things we discussed in the last session. Today, we are taking the same discussion ahead, and then we'll continue. And basically, we are going to represent the three basic equations of motion. Yes, anybody can tell me three basic equations of motion? Anybody on the chat as well? Let's see how many of you know the three basic equations of motion. Yes. Yes, anybody online available on chat? I see there are 5 students available. Please do reply. What are the three basic equations of motion? Anybody can write? Let's see how much you can. And these are very, very important three basic equations of motion, by the way. And on these three basic equations of motion, the whole foundation of mechanics is built, right? Very, very important. Anybody? Okay. Yes, three equations of motion. Let me tell you. V equal to u plus at, that's the first equation. Second equation is s is equal to u plus half at square. And third equation is v square equal to u square plus 2s, right? So we are going to discuss about all these three basic equations. We are going to discuss the proof of all these three equations with the help of which method? Graphical method. So everyone is ready? Yes? Okay. So let us start with this. Yes, these are the 4 topics we are going to discuss. Equation for velocity time relation, equation for time relation, equation for position velocity relation, and special cases for equations of motion. So these are the main 4 topics we are going to discuss. Okay, fine. Now there are 3 sets of equations that are used to obtain the relationship between various parameters that describe the motion, right? So what are these? Yes, as I said, v equal to u plus at, first equation. Second equation is s is equal to ut plus half at square. Third equation is v square is equal to u square plus 2s, right? So these are the three equations. We are going to prove them by using graphical method. Okay. These equations for motion are for those objects that travel with uniform acceleration. Okay. So here in this equation, as you can see, what does this u represent? Are you able to see this u? Yes. U represents what? Exactly. U is your initial velocity. What is v? V is your final velocity. What is a? Uniform acceleration. That's very important to be noted here. These equations are only valid when the acceleration is uniform, right? And what is this t? T is your instantaneous time. Yes. What is this s? S is your distance or displacement, right? Exactly. Very good. So these are same terms. So same is mentioned here. U is your initial velocity, right? V is your final velocity, A is your uniform acceleration, T is your instantaneous time, and S is your distance traveled by the object. कितना distance travel किया है object ने? That distance, or sometimes it is expressed as displacement as well. But for right now, your level, right? For 9th standard, you can just remember S is a distance. It can be used as displacement as well. But that also you have to keep in mind. ठीक है? वो भी याद रखिए. Fine. आगे जाके आप पढ़ेंगे 11th 12th में जब इसके ऊपर क्वेश्चंस करेंगे, राइट? जेई में, नीट में, सीईटी में, तो उस समय आप S can be represented as displacement as well. That also you have to keep in mind. Fine. Now let us derive the first equation. Okay. Now let us consider this graph. Are you able to see this graph? Yes. You remember the graph coordinate system? X-axis and y-axis दो होते हैं उसको, right? X-axis and y-axis. Isn't it? Y-axis is represented along vertical, x-axis is always represented along horizontal, exactly, right? Now here, what is the case of this a straight line? Straight line मतलब uniform है, non-uniform है? कोई बताएगा? Yes, anybody can chat. It's a uniform or non-uniform? This graph represents for uniform or non-uniform? I want the answer. Let's see who gives the answer. Anybody? Akshita, are you there? Please do reply on the chat. Uniform or non-uniform? Let's see who gives the answer. Yes, I'm waiting. Yes. Okay, I got the answer from the Novi. So, welcome to the Swiflearn online teaching. Thank you for reply. It's a non-uniform. Very good. Non-uniform. Just think about it again. It's a straight line. It's a straight line. See, what is the meaning of straight line? Let me tell you. No way. See, as the change in time is proportional to change in velocity. You can see this change in time is 0 to 1 second, to 20, right? Similarly, 1 to 2 second, it's 1 second again. And how much is this velocity? 20 to 30. How much is the difference? 10 again. Now see this difference, 2 to 3, 1 second again. 2 to 3 corresponding to 30 to 40. What's the difference again? 10. Then for 3 to 4, again 1 second. And what's the difference here again? 10. So the change is constant with respect to constant change in time. Are you getting this? So it should be uniform, non-uniform. Yes, now tell me. Anyone? Akshita or Nobe? Yes, non-uniform or uniform? As I explained you, the change is constant, right? Let's see who gives the answer. Uniform motion. I hope you got it. No way? I hope there is no doubt. Okay, very good. Thank you. So it's a uniform motion. Very good. So when do we understand it's a uniform or non-uniform? When the change is constant. The change along x-axis is constant or proportion with respect to change along y-axis. Then we say is that uniform motion, right? I request Nove to you, you can refer to the previous session, the motion session number 3. In that I have discussed about all this uniform and non-uniform. Okay, you can search on our Swiflearn channel. Thank you. So consider a linear motion of an object moving with the initial velocity u. Let the object accelerates uniformly and in time t, it acquires the final velocity v, right? V is the final velocity, and it accelerates uniformly. See, it is also mentioned here uniformly. Okay. So given graph shows the linear motion with uniform acceleration. Acceleration is uniform. That's a very important condition when you apply these equations of motion, and that is being fulfilled here. है ना? Fulfill हो रहा है इधर, तो हम apply कर सकते हैं. Yes. Now let us go ahead. From the graph, as you can see, the initial velocity. Initial velocity क्या है भाई इधर? देखो. OC. OC is your what? Initial velocity. Very good. And what is this OE? Just a minute. Yes. What is this OE? OE is your final velocity. You represent this OE because velocity is along this, right? So OE. Are you able to see this? OE is your कौन सी velocity है? Final velocity. और OC कौन सी velocity है? Initial velocity. Very good. The slope of the line CA gives the acceleration. You remember last session we discussed? Slope of VT graph. ये graph किसका है? देखो, along y-axis is V and along x-axis is time t, right? The slope of VT graph gives you acceleration, right? And the area under this VT graph क्या represent करता है? Area under this VT graph represents, yes, exactly, displacement. Very good, right? So let us calculate acceleration. That is slope. Slope. What is the formula of slope? Rise upon run. Rise. कितना height तक वो rise हो रहा है? And run means horizontal distance covered. Rise is vertical distance covered divided by horizontal distance covered, right? So as you can see this in the graph, acceleration is BA. B से लेके A तक distance है और horizontally C से लेके B तक. Is that clear? If anybody has any doubt, they can ask in the chat section. Okay? Nobaya Nakshita. If you have any doubt, you can always ask. No problem. So BA भी कैसे निकालेंगे? देखो, अभी ध्यान से देखो. BA is basically equal to C because this is EABC is a square. Opposite sides of the square are equal, isn't it? So AB is equal to CE, isn't it? So AB equal to CE है, right? तो C लिख सकता हूँ मैं. देखो इसलिए B को क्या लिखा हमने? C लिखा. उसी तरह CB को क्या लिख सकता हूँ मैं? You see this CB is also equal to OD because OCBD is a rectangle and opposite sides of rectangle are equal, right? तो OD और CB क्या होंगे? Equal होंगे, isn't it? So that's why I can write instead of CB I can write it as OD, isn't it? So CE, अभी CE कैसे निकालेंगे? देखो ग्राफ में CE can be calculated as OE minus OC. Yes, C can be calculated as OE minus OC. तो OE कितना है? That is the final velocity, isn't it? और OC कितना है? That's the initial velocity U, right? So I can write that is this comes out to be OE minus OC, right? OE minus OC is your OE minus OC is your V minus U. And what is OD? OD is your time taken. How much is the time taken? That T, isn't it? So V minus U by T, that's your acceleration, right? So AT is equal to V minus U. So from this, if we simplify further, what do you get? V equal to U plus AT. That's the first proof of our equation. Yes, everyone understood? On the online chat? Yes, very good. Now let us go ahead. First equation of motion, that is velocity time relation, because V represents velocity. Which velocity? Final velocity. U represents which velocity? Initial velocity. A represents uniform acceleration, not just acceleration, it is uniform acceleration, right? And T is your time. तो ये कौन सा relation हो गया? Velocity time relation हो गया. ठीक है? आगे बढ़े? Fine. अभी देखो आगे बढ़े. From the graph, the distance traveled is obtained by the area enclosed between the velocity timeline and x-axis, right? तो area निकालना है अभी हमें. याद है? हमने last class में भी area निकाला था, right? Same we have to do here also. Area. I know you know. This is OCABDO. This is your which trapezium? Trapezium है ना ये, right? तो trapezium का area कैसे निकालेंगे? देखो, area of rectangle. Area of rectangle कौन सा होगा? OCBD. इसका area क्या होता है? Length into breadth. And what is the area of triangle? CAB, isn't it? Right? So half into base into height. You know this, right? So if you write it, the areas. So that is your distance traveled. S is equal to area OC into OD. It's area of rectangle. OC कितना है? U है. OD कितना है? T है ना? समझ में आ रहा है? U into 2 plus अभी एरिया ऑफ रेक्टेंगल देखो, एरिया ऑफ रेक्टेंगल, sorry, area of triangle CAB. What is the area of triangle CAB? Area of triangle is half into base into height. तो base कितना है BC, height कितना है AB, half into AB into CB, right? अभी AB देखो क्या है, AB is also equal to EC. That's what we calculated while calculation of slope, right? So same we can write V minus U, isn't it? तो AB को क्या लिखा मैंने, CE, and C is nothing but V minus U into time T, because CB is your time T. So simplify this, what do you get? S is equal to UT plus AT square. So simple it is. Are you getting this? Anybody has any doubt? Right? So simple. So this is your second equation of motion. And what's that equation of motion for? Position time relation. Because S represents position and T represents time. So this is which equation? This is called as position time relation. Okay, clear? Next, distance travel in time T is the area of trapezium. There is another method now. You can calculate the area of trapezium. Now see here, another method. See, this is your area. Same area we have to calculate, okay? So area of trapezium is equal to half into sum of parallel sides into height. This is the area of trapezium. This is a standard formula for trapezium. This standard formula है trapezium का, ठीक है ना? So half into sum of parallel sides into height. Sum of parallel sides कौन से हैं अभी? OCABDO is a trapezium, right? तो इसमें parallel sides कौन से होंगे? Yes, OC and AD, exactly, very good. OC and AD, these are the parallel sides. So half into sum of these parallel sides, that is plus AD, into height. What is height? अभी parallel का opposite, right? अगर parallel sides vertical है, तो height क्या होगी? Horizontal होगी, isn't it? So OD is a height. Are you getting? So OC plus AD. What is OC? OC is your U, right? And what is AD? AD is your, yes, V, exactly. So U plus V लिखेंगे इधर, OC plus AD के लिए U plus V लिखेंगे into OD. OD is what? Time T, isn't it? Right? So लिखो इसमें. So half into U plus V into T, right? Using the first relation, right? You know what the first relation? Velocity time relation. V equal to U plus AD. उससे क्या मिलता है हमें? T का इक्वेशन मिलेगा. देखो T क्या आएगा इधर से? V is equal to U plus AT, right? So T क्या आएगा यहाँ से? T is equal to V minus U plus V minus U divided by, so simple, right? So T equal to V minus U divided by, put that value here, right? So what do you get? U half into U plus V into T. T की जगह क्या लेंगे? V minus U upon A. तो देखो क्या आता है? इसको simplify करो. U plus V into V minus U divided by A. Now you should use this here equation. A square minus B square is equal to, you might be knowing this, you must have studied that in maths, right? A square minus B square is equal to A square, yes, minus B square equal to A plus B into A minus B, isn't it? A plus B into A minus. Use that here. तो अभी इधर हमें क्या मिला? U plus V into V minus V, or you can write this U plus V as V plus U also. Both are same. 5 plus 3 or 3 plus 5, both are same only, isn't it? So V plus U into V minus U क्या आएगा? V square minus U divided by A. So if we simplify this further, what do you get? V square equal to U square plus 2AS. This is your third equation of motion. Are you getting this? Third equation of motion. And this is your which? Velocity relation. Position velocity relation. I hope everything is clear till now. If anybody has any doubt, they can ask in the chat. If you understood, very good. Please reply. Yes, sir, we have everything till now. I'm waiting for your reply. Yes, no doubt. Yes, let us go ahead now. So these three equations we derived now. First equation was V equal to U plus AT. Right. Second equation was S equal to U2 plus half AT square. And what was the third equation? Third equation was V square equal to U square plus 2AS. These are three equations, right? Now let us proceed. Right. Special cases. Now, what are the special cases? Sorry, some problem. Okay. Yes. Just give me a minute. There was some problem. Could not. Suddenly the window has been stopped to share. Let me open it again. Yes, got it. So I hope the screen is visible to everyone now. Right. So special cases we'll discuss now. Special cases. Previous we have studied about. Sorry for the interruption. By the way, previous we have studied about the equations of motion when initial velocity is u. Right. Now let's obtain equations when the object is initially at rest और initial velocity is zero. अभी rest में है इसका मतलब क्या है? देखो आप लोग अभी मेरा लाइव सेशन अटेंड कर रहे हैं. You are sitting in the room, right? In your room. That means what? You are stationary. आपकी velocity क्या है? Zero है. So any object which is at rest has zero velocity, right? So that is what you can understand, correct? So when u is equal to zero, तो क्या आएगा equation बोलो? b equal to u plus at. इसमें equal to zero डालेंगे तो क्या आएगा? b equal to at. Simple. That's another formula. We can write it. A is equal to v by t, right? That's a formula for acceleration, right? Similarly, s is equal to ut plus half at square में अगर आप u equal to zero डालेंगे तो क्या आएगा? S is equal to half at square. And in the third equation, if you put that same, b square equal to u square plus 2as, put u equal to 0, you get b square equal to 2as. Or in other words, I can say b is equal to square root of 2as, right? Is this clear? Anybody has any doubt? Right? So these are the three equations when the object is at rest. That means their initial velocity is zero. That means they have been started their motion at rest position. Rest से वो चालू हो गया. जैसे आपका vehicle है. When the vehicle starts, it is initially at rest or motion. It is initially at rest, isn't it? जैसे आप कार चालू करते हैं, तो कार स्टेशनरी होती है ना. आप अंदर जाके बैठने से पहले car is at stationary. So it starts at zero velocity. So that is what these equations will be using for those calculation of velocity or distance or initial velocity or final velocity or uniform acceleration, whatever it is, right? So these are the cases when we use when the object is started from rest, whose initial velocity is zero. Is that clear to everyone? Anybody has any doubt? Right? Right. When the object is moving with uniform retardation, sir. Yes, anybody from the chat would like to give the answer? Retardation क्या है? जल्दी से फटाफट से बताओ. Let's see who gives the answer. Retardation. We discussed that in the last session, by the way. देखते हैं कितने लोगों का मेमोरी पावरफुल है. Yes, anybody? Retardation. Acceleration का opposite. Hint दिया मैंने आपको. चलो. Hint भी दिया मैंने आपको. Let's see who gives me the answer. Retardation means what? Opposite of acceleration. Who will tell me? Akshita, Nobe, are you there? Please reply. I'm waiting for your replies. Yes, retardation. Yes, retardation means negative acceleration. Am I right? Right. Retardation means negative acceleration. इसका मतलब उसकी वेलोसिटी कम हो रही है. एक्सेलरेशन मतलब क्या? उसकी वेलोसिटी बढ़ रही है. रिटार्डेशन मतलब क्या? उसकी वेलोसिटी कम हो रही है. सिंपल, राइट? तो अब इसके लिए कैसे लिखेंगे? देखो, तो रिटार्डेशन जब रहेगा, क्या बताया मैंने? माइनस ए डालेंगे, ए की जगह क्या डालेंगे? माइनस ए. सो पुट दैट v इक्वल टू यू प्लस ए टी. प्लस की जगह क्या आएगा? माइनस आएगा. सो फाइनल इक्वेशन वुड कम एज v इक्वल टू यू माइनस ए टी, राइट? इसमें देखो s इक्वल टू u t प्लस हाफ ए टी स्क्वायर है, तो a को क्या डालेंगे? माइनस a. So s equal to ut minus half at square. Are you getting this? Then b square is equal to b square equal to u square plus 2asb. क्या डालेंगे? b square equal to u square minus 2. These are the equations, three equations when your body is retarding. Retarding मतलब उसकी velocity कम हो रही है. Is this clear? Any doubt? Right? Let us go ahead. When the object is falling freely under gravity from a height h, initial velocity u is 0, right? Acceleration a is replaced by g. ये थर्ड केस है आपका. पहला वाला केस हमने कौन सा डिस्कस किया? बताओ जल्दी बच्चों. Dear students, please tell me what was the first case we discussed? Yes, first case when the object is at rest. उस समय हमने उसमें क्या डाला? हमने क्या जीरो डाला? बताइए जल्दी. Anybody would like to tell me on the chart? Yes. Initial velocity is 0. Second क्या डाला हमने? Second case we discussed about retardation, just case, right? So a को क्या डाला हमने? Minus a. Instead of a, we'll put at minus a. And now it is the acceleration a is replaced by g. For which case? When the object is freely falling. Freely falling मतलब क्या? देखो, freely falling मतलब ऐसे. It is freely falling under gravity, right? कोई भी object है particular height से नीचे गिर रहा है. Oh. 1 minute. Right. It's safe, no problem. It's working also. So freely falling मतलब कोई भी ऑब्जेक्ट है हाइट से गिर रहा है, राइट? इसका मतलब a को रिप्लेस करेंगे g से और u को क्या डालेंगे? 0. So let us put them, right? v equal to u plus at, तो v equal to gt हो गया, right? s equal to ut plus half at square. So you put is equal to half gt square. That's what you get. Now it is h here. H is your the height, है ना? कितने हाइट पे है ये ऑब्जेक्ट? कितने हाइट पे है? यहाँ से लेके यहाँ तक हाइट. That is your h. तो s को रिप्लेस करेंगे h के साथ. Getting it? And the third equation, v square equal to u square plus 2s, that comes out to be v square equal to 2gh. s को डालेंगे h और a को डालेंगे g, तो क्या हो जाएगा? v square equal to 2gh. Is that clear? This is the third case we discussed, right? If that's your fourth case, of course that's what we discussed in the beginning, right? अगर u 0 नहीं है तो क्या होगा? Yes, मतलब आपका जो ऑब्जेक्ट है फ्रीली फॉल हो रहा है मगर उसकी वेलोसिटी 0 नहीं है. That means it is not falling from initial velocity, that is at rest, right? Yes, Varsha, hi, happy to see you, welcome to the Swiflearn, right? तो उसकी initial velocity कुछ तो है, तो u0 डालेंगे क्या? u0 नहीं डालेंगे, right? So in that case u will be there. तो इसके लिए क्या होगा? But a should be, because it is freely falling, it's freely falling, that means a की जगह क्या डालेंगे? g डालेंगे, right? s b equal to u plus gt हो गया. s हो जाएगा ut plus हाफ एट, उसमें क्या डालेंगे? u को u रखेंगे और a को क्या रखेंगे? g रखेंगे, राइट? सो h equal to ut plus half gt square, right? And v square equal to u square plus 2gh. These are the three equations when the u is not 0. This is for also freely falling body. Yes, any doubt so far? Fine, let us go ahead. When the object is thrown vertically up, अभी ऊपर डाला है मैंने, ऑब्जेक्ट को क्या किया? ऊपर थ्रो किया, ऐसे ऊपर थ्रो किया. ऊपर थ्रो करने के बाद क्या होगा? ऑलरेडी डिस्कस. ऊपर थ्रो करने के बाद सोचो आपको ज्यादा एनर्जी देनी पड़ेगी. सिंपल एग्जांपल मैं डिस्कस करता हूं. यू टेक अ बॉल okay, and throw it from the third floor. You take a ball and throw थर्ड फ्लोर से ड्रॉप करेंगे आप तो आपको ज्यादा एनर्जी लगती है क्या? यू हैव टू जस्ट पुश इट लिटिल बिट, गिव अ टिल्ट, राइट, एंड इट ऑटोमेटिकली फॉल्स बिकॉज इट इज अंडर ग्रेविटी. मगर जब आपको उसी बॉल को ग्राउंड फ्लोर से थर्ड फ्लोर तक फेंकना है, जितनी ज्यादा एनर्जी से आप ऊपर फेंकेंगे उतना क्या होगा, उसका हाइट उतना गेन होगा, इजंट इट? तो कौन से केस में ज्यादा एनर्जी लगी? दूसरे केस में, व्हेन यू वांट टू थ्रो फ्रॉम द ग्राउंड थर्ड फ्लोर, नॉट इन द केस ऑफ थर्ड फ्लोर टू ग्राउंड फ्लोर, इजंट इट? तो इस केस के लिए क्या लिखेंगे? अभी देखो क्या कंसीडर करेंगे इसमें. इनिशियल वेलोसिटी तो है, राइट, इनिशियल वेलोसिटी u एंड रिटार्डेशन इज इक्वल टू -g. रिटार्डेशन क्यों? क्योंकि जैसे आप ऊपर फेंक रहे कोई भी बॉल को, उसकी वेलोसिटी कम कम होती जा रही है और एक पर्टिकुलर पॉइंट आएगा जहां पर उसकी वेलोसिटी क्या हो जाएगी, 0, राइट. सो व्हेनेवर द ऑब्जेक्ट इज थ्रोन अगेंस्ट द gravity of earth or against the surface of the earth, its acceleration decreases, right? This is what you have to remember, right? तो इसमें क्या आएगा, रिटार्डेशन इक्वल टू क्या हो जाएगा, -g. तो इसमें डालो फिर v इक्वल टू u प्लस at, a की जगह क्या डालेंगे, -g. so what equation you get, v इक्वल टू u minus at. second, h इक्वल टू ut minus half gt square, right? and third, v square इक्वल टू u square minus 2gh. again, h is what here, h is the height raised or traveled or gained by the object. If anybody has any doubt, they can ask in the chat box. Clear है अब तक? कुछ doubt? I'm just waiting for a few minutes. Cannot wait few minutes, by the way, because you have to complete this session. किसी को doubt नहीं है? आगे बढ़ूं? Fine, आगे बढ़ता हूं मैं. Now let us do some interesting things. So, oh, it's not opening. Just a minute. I'll try to open this. It's very interesting thing. Got opened. Yes, it is open now. It's getting open. So I'm sharing you the screen again. Yes, it is. Fine. So let us do something exciting. Right? Everyone is ready? You can see this. This is your basically the graphs of motion, what we are going to discuss today. Okay. So here we have these graphs, position versus time and velocity versus time. Okay. So now let us do something magic here. Okay. Now see here, I'm allowing here to show the instantaneous, right? Instantaneous velocity मुझे चाहिए इसमें. अभी देखो ये ग्राफ पहले, let me tell you about this graph first of all. This is along x-axis is your time and along y-axis is your, yes, distance traveling meter. That's what first graph. Second graph में क्या है? Yes, along y-axis is velocity and along x-axis is your time. Okay, is that clear? अभी देखो ये blue color जो दिख रहा है, blue color in this first graph corresponds to blue color in the second, and the red color in the first graph, that is a curve one, corresponds to red color in the second graph. This is very interesting. Okay, let us do this now. As I am moving this slope, अभी देखो ध्यान से क्या कर रहा हूँ. देखो slope को मैंने क्या किया, उसका जो steepness है कम कर रहा हूँ. Steepness जैसे कम कर रहा हूँ, देखो, are you able to see the second graph blue color line? The horizontal क्या हो रहा है इसके साथ, देखो जैसे मैं स्लोप कम कर रहा हूँ वो हॉरिजॉन्टल लाइन कहाँ जा रही है, नीचे जा रही है. जैसे मैं स्लोप बढ़ा रहा हूँ वैसे क्या हो रहा है, वो हॉरिजॉन्टल लाइन ऊपर आ रही है. व्हाट इज द मीनिंग ऑफ दिस, राइट? एज आई इंक्रीज द स्टीपनेस ऑफ द स्लोप, जैसे मैं स्लोप का स्टीपनेस इंक्रीज कर रहा हूँ क्या हो रहा है, यस, द वेलोसिटी इज आल्सो increasing, but velocity is uniform because it is parallel to time axis. Time axis को parallel है मतलब क्या होगा velocity? Very good. Now let us do some magic with the red color graph. See this second graph में जो velocity time का जो graph है उसमें straight line जो slope आया है उसको मैं ऊपर नीचे कर रहा हूँ. देखो as I increase this slope or steepness, देखो first graph में red graph क्या हो रहा है curve which is a curve one. What is happening with that? Yes, as I decrease क्या हो रहा है वो भी curve आ रहा है. As I increase, what is happening? It is also increasing. Interesting, no? Quite interesting. So why this happens? Because when I increase, of course, this is for non-uniform case because it's a curve one. Curve मतलब non-uniform. जैसे मैं slope बढ़ा रहा हूँ, जैसे क्या हो रहा है? For distance traveled, for time is also increasing. And जैसे मैं आपका slope कम कर रहा हूँ, वैसे क्या हो रहा है? It is decreasing, right? देखो, slope बढ़ रहा है, 1 हो गया. अभी slope कम हो गया. देखो, 0.2 हो गया, 0.17 हो गया. Are you getting this? Very interesting, right? So this is what is with the as you change the slopes change करेंगे आप तो आपके other parameters भी change होंगे. Okay, let us go ahead. अभी time slider use करता हूँ. देखो time को change कर रहा हूँ. Are you getting this? Instantaneous velocity. ठीक है? So time 1.7 लिया. तो ये रहेगा हमारा instantaneous velocity. कितना है velocity instantaneous velocity? 1.42. As I increase the time जैसे मैं increase कर रहा हूँ 2.5 किया मैंने. ठीक है? तो instantaneous कितनी है at 2.5. You are able to see this 2.5. I hope you are getting this 2.5. तो incident velocity कितनी है 2.09, right, meter per second. Very good. If I increase further instantaneous velocity, let's say it is चलो 5 करते हैं. ओके तो 5 के लिए देखो exactly 5 पे आ गया. तो 5 के लिए instantaneous velocity कितनी है सर 4.17. Are you able to see this? Right. So this is how you get. If I keep on changing the time, which time is time, तो आपको क्या हो रहा है corresponding instantaneous velocity we are getting. Okay, now let us drag time on axis. See now, अभी देखो ये टाइम है, जैसे मैं इसको ड्रैग कर रहा हूँ इंस्टेंटेनियस वेलोसिटी वैसे चेंज हो रही है. 4 at time t equal to 4 सेकंड वेलोसिटी कितनी है 3.42. 5 पे कितनी है देखो 5 पे कितनी है अप्रोक्सीमेटली 4.12. 6 पे कितनी है 6 पे ऊपर गया. ओके 6 पे ऊपर गया. आई आउट. यस देखो 6 पे कितनी मिल गया आपको 4.89. 7 पे कितने मिला 5.84. So this is how you can calculate at different time. You can calculate different instantaneous corresponding velocities. Clear? And these are show guides, that is horizontal and vertical. You can see this. These are the horizontal and vertical guides. Basically this is how you plot a graph. Graph plot करते समय क्या करता है पहले सबसे पहले क्या निकालता है. You find out first x and y coordinate and then you plot on the graph, right? That we discussed already in the second session. How do we represent the graph, right? Rectilinear motion second part. Those who have missed, they can go through the video. It's available on our Swiflearn channel. Is this clear? Any doubts so far? Quite interesting, right? Fine. So let us go ahead. Yes, this is done. Okay, now let us discuss some questions now. Okay, everyone is ready with the question? Pen and paper, everyone is ready? So first question for you now. Let me take the annotate. Yes, what is given r with its initial velocity of 20 km per hour accelerates uniformly at the rate of 10 cm per second square over a distance of 100 meter. Determine its final velocity in meter per second. ठीक है. सबसे पहले चीज given quantities लिखो. Given quantities initial velocity u is equal to 20 km per hour. तो इसको convert करना है मीटर पर सेकंड में, right? So how do you convert 20 into, let me change the color. Will not be able to see it clearly. Let me take black. Okay. 20 km per hour. How do you convert? Anybody on the chat? Please tell me. How do you convert kilometer per hour to meter per second? Anybody? Let's see who gives the answer. Akshita, Nobe, Varsha. Anybody would like to tell me the answer? किलोमीटर पर आवर का इसमें करना है आपको कन्वर्ट. यस मीटर पर सेकंड में करना है. Kilometer to meter. How do you convert? 1 kilometer equal to how many meters? 1000, right? And 1 hour equal to how many seconds? 1 hour equal to 60 minutes and 1 minute equal to 60 seconds, isn't it? So 60 into 60 seconds. Very simple, right? So do that then. So 20 into 1000 divided by 3600, right? So this 0 cancel. 200 by 36, right? That is 100 by 18. That comes out to be 50 by 9 meter per second. Fine. Yeah, we have first. Initial velocity is given. Accelerated uniformly. Acceleration भी दिया है देखो. A equal to uniform acceleration है. मैंने बताया था आपको ये तीन equations कब valid होंगे when the acceleration is uniform. That is what you have given. So that acceleration is 10 centimeter per second. तो centimeter का meter में convert करो. What's the conversion? Anybody? 1 meter equal to 100 centimeter, right? So 1 centimeter equal to 10 raised to minus 2. Very good. So 10 into 10 raised to minus 2 meter per second. That comes out to be 10 raised to minus 1 meter per second. Very good, right? A distance there, s is equal to 100 meter, right? What you have to find, by the way, in this question, we have to find out final velocity v निकालना है v. अभी बताइए कौन बताएगा मुझे? Which formula you use? S equal to ut plus half at square, v square equal to u square plus 2s, or v equal to u plus at. Yes, which equation you'll go for? Anybody on the fact? Please reply. Yes, which equation? In fact, you can use any of this. V equal to u plus at भी use कर सकते हैं, but उसके लिए time चाहिए, time नहीं है हमारे पास, right? But s दिया है देखो, s तो कौन सा use करेंगे? V square equal to u plus v square equal to u square plus 2as, right? तो u square, u कितना है? Initial velocity 50 by 9 bracket square plus यूनिफॉर्म एक्सीलरेशन दिया है कितना है 10 raised to minus 1 और डिस्टेंस भी दिया है डिस्टेंस कितना है 100 मीटर. So do this calculation, you'll get the answer. Is that clear? Now calculation is pretty simple, you can do that. Let me see, check the answer also here. Okay. Yes, what is the answer we get? Yes, see, same equation. First you have to convert all the things in meter per second, na? That you have to keep in mind. Okay, then use this equation v square equal to u square plus 2s and do the calculation. You get v equal to 7.08 meter per second. Is that clear? Any doubt so far? Yes. Okay, let us go ahead. Second question. So falls in gravity from rest and reaches the ground at time t. Under gravity है मतलब कौन सा है free fall and starts from rest. इसका मतलब u क्या होगा आपका? Yes, u should be 0. Initial velocity would be 0, isn't it? Initial velocity u 0 and reaches the ground at time t. Ground पे reach होने के बाद time कितना है t? Write down the expression for the height fallen by the object. Yes, anybody would like to give me the answer? Height का equation लिखना है हमें. Height is basically distance. Right? S का equation use करना पड़ेगा. S equal to ut plus half at square. Yes. So let us do this. Isn't it? So what equation? Under gravity है तो A क्या होगा? Right? And we have to find out the equation of S is equal to क्या होगा? H. तो क्या use करेंगे? S is equal to ut plus half at square. Isn't it? But it starts from the rest. तो u क्या होगा इधर हमारा? तो क्या होगा? Equation 0 plus half gt square. ये होगा h. This gives me h is equal to half gt square. That's your equation. Is that clear? Pretty simple, right? बहुत simple है. चलो देखते हैं इसका आंसर क्या है. Let me clear all the things first. We are right. H equal to half g square. Let us go to the third. A truck starts moving on a highway and after 10 seconds, it acquires a velocity of 20 meters per second. Determine its acceleration and distance traveled in this time. We are supposed to calculate acceleration and distance. ठीक है, दो चीजें निकालनी है. चलो ट्राई करते हैं इसको. Starts moving on a highway and after 10 seconds it acquires a velocity of 20. So what is given after time t, after t equal to how much time? 10 seconds, it acquires velocity of 20 meter per second. ठीक है ना? क्या निकालना है हमें? Acceleration. What you have to find? हर क्वेश्चन देखो याद रखो ऐसे सॉल्व करना है. First write down given quantities in the notation form, not in the wording forms. Then write down find out quantities in the notation form and then go follow. So very simple, right? तो निकालना क्या है? Acceleration. A equal to question mark. स्मॉल में लिखना है, okay? और उसके बाद क्या निकालना है? Distance traveled s. ये चीजें निकालनी है. अभी बताइए मुझे which equation will go for? कौन सा equation is coming? Anybody on the chat can tell me? एक्सेलेरेशन निकालना है और s निकालना है. एक्सेलेरेशन का तो फॉर्मूला आपको पता है, a equal to rate of change of velocity, isn't it? Right. A truck starts moving on a highway and after 10 seconds. इसका मतलब starts from rest. Of course, truck has to have addressed initial condition, right? Initially वो rest होना चाहिए. तो इसमें u क्या होगा? 0 होगा. तो इसमें v क्या होगा? v should be equal to yes. तो हमें होगी 20 मीटर पर सेकंड. तो एक्सेलरेशन का फॉर्मूला a is equal to v minus u by t. अभी u तो 0 है, इधर u क्या है? 0 है. तो क्या हो जाएगा ये? v is how much? 20 divided by time. Acceleration 2 meter per second square. Simple. Are you getting this? Right. So acceleration कितना हो गया? 2 meter per second square. Right. Then they have asked to find out distance travel. Distance travel के लिए कौन सा यूज करेंगे फॉर्मूला? S is equal to ut plus half at square, right? U तो 0 है, 0 plus half into 2 into time कितना है? 10 सेकंड दिया है, right? तो कितना हो जाएगा? 100 meter. That's your answer. These are your answers. Any doubts so far? Is that clear? Right? Pretty simple. Okay. Let us go ahead. Oh, I need to clear this first. देखो सही है हमारा. एक्सेलरेशन कितना आया था? 2 मीटर पर सेकंड स्क्वायर और डिस्टेंस ट्रैवल 100 मीटर. दैट्स ऑल. दैट्स डन. वी आर डन विद दिस टॉपिक. सो व्हाट discussed so far in this session today? Equation for velocity time relation. Can anybody tell me what is the equation? Velocity time relation का equation क्या है? तो बताएगा? जल्दी फटाफट बताओ. हमारे सेशन खत्म होने आ रहा है अभी. Yes, velocity time relation. Velocity और time का relation क्या है? V equal to u plus ad. Very good. Position time relation. Position means distance. S. S equal to u plus half at square. Position velocity relation. That is v square equal to u square plus 2as. Right. And special cases we discuss. Basically we discuss which cases? 4 cases. पहला वाला केस कौन सा था? जब ऑब्जेक्ट रेस्ट पे होगा तब u equal to 0 डालेंगे. केस भी डिस्कस. राइट. फर्स्ट केस कौन सा डिस्कस किया हमने? Just a minute. Just take a quick recap for this. Things will be fine. So इसमें हमने पहला वाला केस कौन सा डिस्कस किया? पहला वाला केस u to 0 रहा था, रेस्ट पे होगा. दूसरा वाला केस yes, it is falling from the height, right? तो a equal to क्या डालेंगे? g डालेंगे, right? और s is equal to क्या डालेंगे? h. तीसरा वाला केस कौन सा था? Yes, third case was when it is thrown above the surface or against the surface of the earth. तो क्या हो जाएगा? a equal to क्या हो जाएगा इधर? minus g हो जाएगा. Are you getting this? और तो h ही होगा, right? And fourth case was अगर free falling body का अगर object initially u velocity के साथ रहता है तो u is not equal to 0, a equal to minus g and s is equal to h. So these are cases we discussed. Okay, is that clear? Fine. So I hope the things are very clear, and I hope I have made the things very pretty simple for understanding. Your understanding, आपको बहुत अच्छे से समझ में आया होगा. Before I end this session, I want to thank. That's first and foremost. Thank you very much for joining us today. And before ending, this is very important. Please subscribe to our channel. Don't forget to press a icon so that you don't miss any of our live sessions. Okay. So hope to see you in the next session. That is the fifth session. We are going to discuss motion part fifth. And please like our videos and your friends and make as many subscriptions as possible. Okay. Please spread the word because जो भी चीज अच्छी होती है उसको spread करने के लिए time ही waste करना चाहिए, right? Immediately you spread. So hope you enjoyed this session. So meet you again soon, day after tomorrow, for the fifth session of motion. Okay. Thank you for joining. All the best. Bye bye. Take care. Be at home. Be safe and